As I stated in the intro video, if you remember how to do linear regressions, this is almost the exact same process. We just have one different step that we need to type in a quadratic regression and not a linear regression. But as a reminder, when we make scatter plots, this is more for my on-campus students. When you make a scatter plot, you need to make sure that you are just plotting the ordered pairs on the graph. Do not connect them. Do not make that line of best fit. A scatter plot is just that. It is a scatter of that data. So do not connect the lines because you will get counted off on the attendance quiz and on your test. Now, to make them in Desmos, we have 4 steps. We're going to add an item, select table, we'll input the data, and I've highlighted this because this is so important, guys. Just please check your data. It takes 3 seconds to check it, but if you don't check it and you get one number wrong, your whole thing's going to be thrown off. So make sure you check it and don't get the question wrong because you imported a number wrong. And then lastly, click on the magnifying glass. This is your zoom fit feature, and so it will make that scatter plot fit into that window nicely. So then to make a quadratic regression, we will make the scatter plot, which is what we hopefully already have done. And then we're going to type in a new line our quadratic regression. Now, because this is a quadratic regression, if we remember our quadratic function is y equals ax squared plus bx plus c. So what I'm typing in for my regression is almost this, except it's going to be this, right? Remember, our data has it labeled as x1 and y1. So instead of y, I need y1. Instead of this equals, what tells Desmos that we're doing a regression is that we will do that squiggly line. I think it's called a tilde. And then we'll have ax squared, but that other line is labeled as x1. So I need those variables to match. And so this will be x1 plus bx. Again, that variable needs to match. So x1 plus c. So let's try this here. And if you want to kind of use these steps, keep them handy. But I'm just going to kind of go through the steps to do this data right here. Okay, so I already have Desmos pulled up here. And I'm sure you guys know, I really don't like all these minor grid lines, so I will turn those off because those drive me crazy. Okay. So first thing we need to do is make a scatter plot. So I'm going to add an item, and I'm going to add a table, and I'm going to type in my data. So if I go ahead and actually split the screen, I'm going to put in my X column into my X1 column. So we have 0, 2, and then now it's guessing what the next entry will be, 4 and 6. So this one only has 4 points. And then I'll type in my f of x, which we know is the same as y, into my y1 column. So we have negative 1.62, 18.58, 63.42, and 132.9. Okay, so there are my 4 points. Now, after we input that data, please check it. This one's even easier to check because there's not very many points, but got 0, 2, 4, 6, negative 1.6, 18.58, 63.42, and 132.9. So my data matches. Once I've inputted that and I like it, I'm going to hit this zoom fit feature. And now I can see all of those data points right there on my graph. Okay, so that is my scatter plot. For my on-campus students that are doing this by hand, you are simply just plotting those ordered pairs, right? That's not really a thing you need Desmos for. So now I want to make my quadratic regression, and I guess we should probably start by reading this, right? Example 1 tells us to find the quadratic regression, so the quadratic function That is the best fit. That right there is your terminology that tells you regression. For f of x defined by the table below, we are going to round to the nearest hundredth, okay, which is 2 decimals. Okay, so once we've made that scatter plot, now we'll type this into our second line. So I have, and I'm going to make the mistake you guys will make just to kind of reiterate my point. If I do y tilde, because you guys are good at remembering that, usually, tilde ax squared plus bx plus c, okay, you get a little caution or a little warning sign. That is your hint that, hey, my variables don't match. Up here, it's x1 and y1, but down here, it's just y and x. So I'm going to go over here to the right side of those. And when I type in a 1, it automatically puts that as a subscript. And now I can see this table right here. So they tell me what my A, B, and C is. And luckily it says round to the nearest 100, and that's what all of these are right here. These are all 2 decimal places. So we will have y equals my A. I'll highlight this just for effect. Okay. My A is 3.08, and that goes with the variable of x squared, plus my B equals 3.94. And that goes with x. And then plus my constant of c. So I've already put a plus. I can do plus a negative 1.62, but honestly, plus a negative, same as just minus. I'm going to do minus 1.62. And there is my quadratic function that is the best fit for this data. Now, in all actuality, it's not just the best fit, it's an exact fit. Because my r squared equals 1, that means this is an exact, or this function here is the exact function for this data right here. So it is a perfect regression. Now, before I end this video, I do want to kind of show you guys something, because before we even put in this regression, we probably should have looked at that data and determined, is that the best thing we should use? Now, the example does tell me specifically use a quadratic function, but you can see that these points, yes, they do have a slight curve, but honestly, they kind of look like they're in a straight line. So if you never know which one to use, type them both in and see which one gives you a better r or r squared. The goal is to get closer to 1. Right? So if I do y1 tilde, my linear equation is mx plus b. So mx plus b, but I have a caution symbol because that variable does not match. So you can see here, if we compare r squareds, here my r squared is a perfect 1. This one here has an r squared of 0.94. So what that means is that r squared for a linear function, that's still pretty close. Now you can see all of these points are off of that line, right? So it's not exact. Exact would be something like this one, where it hits every point perfectly. But by all means, that r squared is not super bad. I mean, anything in the 0.9s is decent, but you can see this quadratic is a better regression. But if you ever don't know which one, if it kind of looks like, that could be a line or that could be a parabola, a quadratic, type them both in and see which one is closer.